I myself, Dr. Mahanti, welcome you for this session. Now, today I will teach you group 18 elements in the composite study and their compounds. In the group 18, first we will study number 1, what are the elements present in group 18? First, elements present. Elements present. Helium, He, neon, Ne, argon, air, krypton, Kr, xenon, Xe, radon, Rn. The symbols it contain the 6 elements: helium, neon, argon, krypton, xenon, radon. Among these, the radon is a radioactive element. It is a radioactive element. Radioactive. What is others? We can find out. Its electron configuration. First, electronic configuration. Electronic configuration. In the electron configuration, helium 4 1s2, helium 1s2, it contains atom number 2, atom mass 4, 1s2. Neon 1s2, 2s2, 2p6. Argon 1s2, 2s2, 2p6, 3s2, 3p6. Krypton 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Similarly, xenon last is 5s2, 5p6. Radon 6s2, 6p6. So, we find here, except this first, it contains 2 electrons in the outermost shell. It contains 2 electrons in the outermost shell. Which is stable because it is first shell. Shell is the first shell. First shell, if it contains 2n square, that is 2 into 1 the square, it is all 2 electron. It is also stable. Now, this is contained in the outermost shell. All these elements contain in the outermost shell 8 electrons. All these contain 8 electrons in the outermost shell. Since these all the elements we find contain 8 electrons or fulfill octet rule, that is called octet rule. Octet rule, that is contain 8 electrons in the outermost shell. In the first shell, helium contain 2 electrons. Hence, they all are contain stable electronic configuration. All contain stable electronic configuration. Due to stable electronic configuration, they are called noble gases. Due to stable electronic configuration, they are called noble gases. Kahin noble gas kuha jaye? Tame kahiba because they contain 8 electrons or 2 electrons. First is 2 electrons, others 8 electrons in the outermost shell. It is called stable electronic configuration. Then we go to the occurrence of these elements. Occurrence. In the occurrence, first helium occurrence, except radon, which is radioactive element, the others found in atmosphere, others found in atmosphere. In atmosphere. Radon atmosphere nahi, but others are remain atmosphere. Atmosphere. In dry air, 1% is of argon. 1% of argon is the major constituent. Is the major constituent. Major constituent. ताले सब argon टा जी 1% argon is the major constituent. Helium and neon are found. Helium. So all the elements that among that argon contain atmosphere 1% in dry air. Then helium and neon sometimes found. Helium and neon are found minerals of radioactive origin. Minerals like pitch blende, that is uranium. Laterally, monazite, having radioactive minerals having radioactive origin, ताले बर्तन आर्गन भी अच्छी सब एयर अच्छी एक्सेप्ट radon all there 1% argon their major product in dry air. Helium and neon found in minerals like pitch blende and monazite. A main source of helium is natural gas. From natural gas we also get helium. The main source of helium main source is natural gas. Natural gas is content. Rn is obtained by decay of radium. Radium decay करागला हम भांगी परिवार radium 88 mass is 226. It give Rn 86 222 with helium. It give alpha particle He24. So this we get radon is obtained by disintegration of decay of radium. Now this is the occurrence of noble gases. Question may be asked, why? Group 18 elements, question is given you, one question, why group 18 elements are called noble gases. Are called noble माने कासे रिएक्ट करे नहीं सहजरे noble gases by inert gases. Noble gases or inert gases. Your answer is because by the electron compression we found that helium contains 2 electrons in the outermost shell. Answer is 2 electrons in the outermost shell. First outermost shell. खाली outermost shell लिख दिया. outermost shell. Others neon, argon, krypton, xenon, radon contain 8 electrons, which are all contain stable electronic configuration. Due to stable electron configuration, it is not capable to react with other elements. Hence, it is called noble gases. Then some ionization enthalpy. some characteristics ionization जेतबे ग्रुप डिस्कशन हम करवा सेतबे एगुड़ा सब डिस्कस सबुतर हम करियो पड़िबो आयोनाइजेशन एंथैल्पी व्हाट इज आयोनाइजेशन एंथैल्पी in the previous class I have told you the energy required to pull out the outermost electron from the isolated neutral gaseous atom is called ionization enthalpy. So when A gives A plus E minus, some energy is supplied, this energy is called ionization enthalpy. This energy is called ionization enthalpy. You have to supply some energy. By supplying some energy, one electron can be moved. They are both stable electron configuration. Due to stable electron configuration, it is very high ionization. Due to stable, बहुत difficult है ना electron भाग करने पे. Stable electron configuration, they have all the elements have high ionization enthalpy. All the elements have high ionization enthalpy. And the ionization enthalpy similarly decreases both high and decreases down the groove. So ionization enthalpy of helium, neon, argon, krypton, xenon, radon gradually it decreases. It is very high, it is very high ionization enthalpy, very high ionization enthalpy. Size B, ionization enthalpy B size. Look at it contain 1:2 second cell, it contain 3 cell, it contain 4 cell, 5, 6 like this. Due to helium contain 1:2, it is first cell. It contain 1:2, 2:2 is second cell, third cell, 4 cell, 5, 6. Number of cells increases. As number of cells increases, as the number of cells increases from helium to radon, then the size increases from top to bottom, from going to bottom, but top to bottom, from top to bottom. ionization कम होता किंतु ये बढ़ला साइज टा बढ़ी होची. So decreases, this is increases down the groove. Electron gain enthalpy. Then we'll go number C. Electron gain enthalpy. The energy released when one electron is added to gaseous atom. Suppose A is a gas atom, A gas plus E, it form A minus. Then you have to add an electron plus some energy released. This energy is called electron gain enthalpy. The energy released when electron is added, set electron बाहर तो ionization रे. एटे electron gain means उटे electron gain कला. Gain कला परे जितने energy में release होला, that is called electron gain enthalpy. This energy is called electron gain enthalpy. The electron gain enthalpy, since they have stable electron configuration, since they all have stable electronic configuration, stable electron configuration, they have no tendency, they have no tendency to accept electron, accept करियर ता कैपेसिटी नहीं, because they are stable. Hence, it is high positive. So, and this elements has very high positive electron gain enthalpy. High positive electron gain enthalpy. That सब noble gas गुड़ाक that high positive electron gain enthalpy. The negative positive electron gain enthalpy. Then is there monoatomic, number D. They are all monoatomic. Monoatomic. Jimmy the oxygen am got diatomic O2, nitrogen got N2, fluorine got F2, but here helium neon they are not He2. That is helium monoatomic remain as He, neon remain as Ne, argon remain as R, air, krypton remain as Kr, xenon remain as. So they are all are remain as monoatomic. They are colorless, all are gases, all are gases, all are gases, all are gases, yes. And they have low melting point, boil point. Tapar number D have low, very low melting point, melting MP and BP and boiling point. That is why they have low melting point and boiling point. One point is या कायसा मिसी पाउनाहांती कंबाइन सेटा हेई परिबनी. देयर इज वीक डिस्पर्सन फोर्स, नो इंटर डिस्पर्सन, नो इंटर एटॉमिक फोर्सेस. कहीं से बहुत लो टेम्परेचर, लो मेल्टिंग पॉइंट एंड लो बॉइलिंग पॉइंट, लो मेल्टिंग पॉइंट, लो बॉइलिंग पॉइंट. व्हाई यू हैव टू आंसर दैट दे हैव नो इंटरेक्शन फोर्सेस, किसी इंटरेक्शन फोर्स नहीं, and weak dispersion force and weak, very weak এই দুটা পয়েন্ট কথা লিখিব dispersion forces. গোটে হলা no interaction forces and weak dispersion forces. So this all about some characteristics of electroconformation. Then we'll go ionization enthalpy, electron gain enthalpy, size, melting point and boiling point. Then we'll go some chemical properties. Some chemical properties. Xenon forms fluoride compound. Number one, it only forms fluoride compounds. Fluoride compounds of xenon. Fluoride compounds of xenon. A structure we कही पड़े हमको. Fluoride compound xenon. Xenon forms a number of fluoride forming xenon difluoride, XiF2. It is called xenon difluoride, xenon difluoride, XiF4 तीन टाइम करे xenon difluoride, xenon tetrafluoride, xenon tetrafluoride, XiF6 it form xenon hexafluoride. तीन टा फ्लोराइड अब xenon करे, मेस्टिक xenon भी करे केवल xenon difluoride, xenon tetrafluoride, xenon hexafluoride. When xenon किमता में तैयार हुए देखो, first preparation of xenon difluoride हमने लिया. When xenon is treated with fluorine gas, excess xenon plus fluorine gas at temperature 673 K, pressure 1 bar, we get xenon fluoride. Preparation of xenon fluoride. एक नंबर पड़ जाए. Excess xenon, you have to take excess xenon नेला नबा, fluorine दबा, देला परे. Temperature is 673 K, pressure is 1 bar. At that case we get xenon difluoride. And xenon tetrafluoride will get when xenon 1:5, xenon plus 2F2 G, we get temperature is 873K 7 bar pressure, we get xenon tetrafluoride. Here ratio of 1:5. Ratio 1:5 ratio of xenon to fluorine. Xenon the 1% naba, 5 types naba fluorine. We get xenon tetrafluoride. Temperature is mentioned 873K and pressure is 7 bar pressure. And xenon hexafluoride similarly 3टा अगर आम xenon सहित फ्लोरीन मिशन एटी xenon सहित फ्लोरीन एटी मत xenon सहित फ्लोरीन एटी कौन करवा आम xenon G plus 3F2G we get the temperature is 573K 60 to 70 bar बहुत हाई प्रेशर ना हबनी 70 bar we get XII गोटे मेथड ये गोटे मेथड पाइबा ए रेशियो नबा 1:20 इट इज इम्पोर्टेंट रेशियो इज 1:20 दा माने 1 टाइम जदि xenon नबो इज 20 टाइम्स हम नबा फ्लोरीन एटी नबा बे 1 जदि फ्लोरीन नबा 1 इज एक्सेस xenon एटी 1:5 एटी खाली xenon एक्सेस फ्लोरीन टा कम जदि ए बडा करबा वी कैन प्रिपेयर xenon डाइफ्लोराइड xenon tetrafluoride and xenon hexafluoride. In the xenon hexafluoride also can be obtained from xenon tetrafluoride B. Out method are B. Second method, when xenon tetrafluoride is treated with oxygen fluoride, we get XiF6 plus O. Theta method. So this is the first xenon forms 3 fluorides. One is xenon difluoride, xenon tetrafluoride, xenon hexafluoride. But you write the preparation. You write the preparation means when xenon tetrafluoride सबुतिरे xenon सहित फ्लोरीन देला आम XiF2 पाइबा XiF4 पाइबा XiF6 पाइबा किंतु कंडीशन इज हियर इज प्रेशर इज 1 bar. You have to remember pressure will be 1 bar, temperature is 673K. Here is pressure is 7 bar and the temperature is 873K. Here is pressure with high pressure, that is 60 to 70 bar and the temperature is 573K and the ratio is 1:20. We get xenon difluoride, xenon tetrafluoride and xenon hexafluoride. Now very important is that the structures of this. What is the structure of xenon difluoride, tetrafluoride and hexafluoride? Let us discuss the structures of. This is the preparation. Structures of xenon first we start structure of xenon difluoride. Xenon difluoride XiF2 very simple way बुझे देबी structure केमते भाईबा. Structure of xenon difluoride. Here xenon is there. Xenon दा atomic number outermost cell আছে 5s2 5p6. outermost electron configuration, outermost electronic configuration, electronic configuration. The outermost electron at xenon is 5s2 5p6. So you write 5s2 structure लिखिबा 5s2 5s2 5p6. Here is availability of 5d orbitals 1 2 3 4 5. It is 5d orbital. 5d कितना 1 2 5 orbitals vacant. Since there is how many fluorine? 2 fluorine in there. 2f. 2f. Each fluorine has fluorine atomic number 9. It contains 1s2 2s2 2p5. That means 1 p orbital remain as partial field. देखिए one this orbital remain as partial field. ताल देटा फ्लोरीन अच्छी we have to make 2 orbitals partial field. मोटे नहीं वर्तमान. In order to make 2 orbitals partial field, 1 electron from 5p orbital jumps to 5d orbital. You jump 1 electron from 5p to 5d at a ground state. In the excited state, 1 electron you jump करो. XII state 1 jump kala pare asibo so this 2 3 4 5 3s s p d. Then come arises third point, what type of hybridization? Here 1s orbital 1s 3p orbital tapare and 1d orbital mixed together to give sp3d hybridization. It daba hybridization kon sp3d hybridization. It give sp3d. Since it give sp3d hybridization, you have one fluorine is there, got orbital fluorine, no got a fluorine, got a electron, it goes to here, p orbital of fluorine, one orbital partial field, p orbital goes to here. Overlap kala pare, but the structure will be sp3d means it is sp3d panchta trigonal TBP trigonal bipyramidal haba katha, trigonal bipyramidal. তাহলে XC F 2 bond pair, it contain 3 lone pair. It contain this lone pair, you see, it is one lone pair, one lone pair, one lone pair. This lone pair remain here, and the bond, this is bond pair, the bond pair electron, it is bond pair. So this is the bond pair electron, bond pair, electrons in bond pair, and this electron is bond pair, and this is lone pair, and lone pair. And the shape is of xenon difluoride is linear. Shape is linear. Its hybridization is sp3d. Hybridization is sp3d. And contain how many lone pair? 3 lone pair and 2 bond pair. जो कौन सा question बल्ले करी परिवो? For the shape of xenon difluoride, the answer will be the shape of xenon difluoride is linear. It contain how many lone pair electrons? 3 lone pair. How many bond pair? 2 bond pairs. Because duita achi fluorine, 2 bond pair. This is the structure of xenon difluoride. Now we have to go to xenon tetrafluoride. Similar manner, I am explain kariba xenon tetrafluoride. Xenon tetrafluoride. One xenon, 4 fluorine is there. Xenon tetrafluoride. Similarly, xenon 5s2, 5p6. So box diagram kari pariba 5s2, 5p6, 5s2, 5p6. Simple way, we may write 5s, 5p. Now the point is, seeing there are 2 fluorine by the type of 2 tika. But then ketra fluorine is 4 fluorine are there. So we have to make 4 orbitals partial field. Ame 4 orbital go 2 tika rakhiba ko paribo. Jodi go 2 re 4 rakhiba, tale fluorine saita ta sath bond kari paribo. Hence, in order to make 4, it is a ground state. It is ground state. In the XII state, कौन हबो 1 electron from 5p, 2 electrons from 5p goes to 5d. देखला हो हला कि 5s रहला this 2 1 1. Say very simple way. So 1 1. So this is हम like this चारटा रहला हमर ऑन पैर जो फ्लोरीन जीवो तापरे then कि प्रकार हाइब्रिडेशन हम 5s 5p 5d देखला पहले 5s रहला गोटे 5 रहला 3टा 5d रहला 2टा जेहेतु 1 5s 3 5p 2 5d 1 5s ऑर्बिटल 3 5p orbital and 2 5d orbital are there. তাহলে কি প্রকার হাইব্রিডেশন হবো? It will be sp3d2. It will be sp3d2 hybridization. It contain how many lone pairs? It contain how many lone pairs? sp3d. It contain 2 lone pair is there in hybrid orbitals. So it is the shape of general tetraplet square planar. The kim hochi XEF4 XE F F F F. It contain 1 lone pair. Here it contain 1 lone pair. It contain lone pair, bond pair, bond ko jora bond electron, bond pair, dita electron. Fluorine gote, chatta fluorine achi. Orbital overlap kala. So what is the shape of general tetraploid? The answer will be square planar. How many lone pair electrons are there? 2 lone pair. How many bond pairs are there? 4 bond pair. It contain, answer will be 4 bond pair, 2 lone pair. Lone pair remain in this side on axial position. In the equatorial position remain as the bond pairs. Then we will go to xenon hexafluoride. Similarly, xenon hexafluoride. Xenon hexafluoride. Its formula is XCF6. ଯେମିତି XCF2 ଆମେ କରିଥିଲେ 2 F4 F6. That means 6th fluoride there. then 6ଟା ଆମକୁ ଅଟୋଟିକା ରଖିବାକୁ ପଡ଼ିବ. xenon is 5s2 5p6. So it is 5s2 5p6. তাহলে তুমি সেমতি কହୁଥିଲେ দুইটা করଥିଲେ তারপর 4টা কলে এটি 6টা আমি অলগা করিবা কলে কোন আসবে দেখ 5ps 5p গোটেটিকে আমি 6টা রাখিବାକୁ পড়িব 1 2 3 4 5 এটা হল 1 2 3 lone pair. Hello. So here the hybridization will be তিনটা হল 1 2 3. The hybridization is sp3d3. The hybridization is sp3d3. Here is gote hela 5s, 1 hela 5s, 3 hela 5p, 5d. Tale 1 5s, 3 5p and 1 5d mixed together to give sp3d3. 3 5d. Look at here 5d কেটা আছে তিনটা 1 2 3 it form sp3d3 hybridization. And the shape is distorted octahedral. Distorted octahedral having 1 lone pair, 6 bond pair. It contains 1 lone pair and 6 bond pair. So this is all about the structure of xenon difluoride. Then shape ala tinta amar fluorine ala XCF2 taku part par lekhi dauchi. Then xenon difluoride shape is hybridization is sp3d. Shape is emti kade lekhibo. Shape is linear. It contain 3 lone pair and 2 bond pair. Xenon tetrafluoride XCF4, it is sp3d2. It contain 2 lone square planar, shape is square planar. It contain 1 lone pair, 1 2 2 sp3 2 3 6 रोच 2 lone pair and 4 bond pair. XCF6, the hybridization is sp3d3. The shape is distorted octahedral, distorted octahedral. It contains 1 lone pair and 6 bond pair. This is all about the structure of fluorides of xenon. Some of the reactions of fluorides of xenon, some reactions of xenon fluoride. Reactions first will be action with water. Action with water. Action with water. Xenon difluoride react with water forming xenon difluoride plus H2O. Xenon difluoride when combined with water 2H2O balance कर दो balance कर लिख दो 2XF2 equal 2H2O you will get 2XEG plus 4HF plus oxygen gas. Balanced equation. Similarly, XCF2 ଆମେ xenon ପାଉଛନ୍ତି. Similarly, 6XF4 tetrafluoride XF4 plus 12H2O balance कर लिख दो क्या बोले 4Xe plus 2XeO3 xenon dioxide plus 24 HF plus 3O2. Xenon dioxide preparation, this is preparation of xenon dioxide. Similarly, on partial hydrolysis, xenon hexafluoride plus H2O we get XeO4 xenon oxy tetrafluoride plus 2HF. Similarly, XF6 plus 2H2O dita reaction excess কিছু রখি দেলা পরে it will be XeO2F2 plus 4HF. See the reaction with water. Then it also react with xenon fluoride, react with phosphorus pentafluoride, antimony pentafluoride. কেমনি রিঅ্যাকশন করছে রিঅ্যাকশন উইথ ফসফরাস পেন্টাফ্লোরাইড এন্ড অ্যান্টিমনি পেন্টাফ্লোরাইড Pakadala question, what happens when xenon difluoride treated with phosphorus pentafluoride? XCF2 xenon difluoride plus PF5 phosphorus pentafluoride the cation would you will get XCF গোটাই পাপ উপরে আসব XCF plus this is plus XCF plus PF6 minus important PF6 minus your question পড়লে করি পারিব it form addition compound forming cation and anion but salt color XCF plus PF5 similarly XCF4 plus PF5 PF5 or SBF5 similar manner SBF5 similar with a fluid commutativity will get XCF3 plus this is plus F का प्रोडक्ट ठीक है ताले SBF6 minus question पर सीधा इतनी लग दल मार्क पाई SBF6 minus it form a addition compound of this with a cation forming cation and anion but xenon hexafluoride react with MF MF टा कौन कही भी M टा कौन M is where M is sodium potassium rubidium or cesium either sodium fluoride पड़ू किंबा potassium fluoride हो किंबा rubidium or cesium alkali metals यदि मिसिबो it form एटी उल्टा आइबो एटी M plus plus XCF7 XCF7 minus M plus. It will be M plus. Sodium pai haba Na plus. X F paku eti F palaibo. Eti gote kala X paku F palai asla. Eti F ta a paku jautala. Eti F ta thik change hochi. You will get F paku asla bartaman. XCF7 ta minus haba. Eti plus X ta plus hotala. Eti X ta minus hala. Eta mone rakhiya pore tumku. When xenon hexafluoride treated with sodium fluoride, ta mane xenon hexafluoride when treated with sodium fluoride. What happens when xenon hexafluoride treated with sodium fluoride? Answer will be xenon hexafluoride plus sodium fluoride. Sange sange likhibo, you will write Na plus XCF7 minus. सेठी उल्टा हो भूल हो सेठी सेजियम जेमती होता अलग टाइप एटी अलग टाइप फॉस्फोरस आर्सेनिक अलग होता आम जेनोन ट्राइऑक्साइड कथा कहते प्रिपरेशन जेनोन ट्राइऑक्साइड फॉर्मूला ऑक्साइड ऑफ जेनोन किसी गोटे करवा दिस ऑफ द सम फ्लोराइड्स ऑफ जेनोन सम ऑक्साइड्स एंड ऑक्सीफ्लोराइड्स ऑफ जेनोन oxides and oxyfluorides of xenon. Fluorides of xenon. Which oxides and oxide. Xenon forms oxide, xenon trioxide, XiO3. Mainly oxide XiO3, xenon trioxide, XiO3. ମୁଁ କହିଥିଲି କେମିତି ପ୍ରିପେୟାର ହୁଏ ବୋଲି ଟିକେ ଆଗରୁ କହିଥିଲି ଦିସ୍ କ୍ୟାନ୍ ବି ପ୍ରିପେୟାର when xenon tetrafluoride, the preparation when xenon tetrafluoride is treated with 6XF4 12H2O, we get 4Xe plus 2XiO3 preparation xenon trioxide plus 24HF आगे भी कही रिपीट करची plus 3O2. So this compound xenon trioxide what is the structure केमी structure हम देखिबा what is the structure of xenon trioxide की प्रकार हाइब्रिडेशन हम की प्रकार structure हम let's discuss xenon trioxide structure. Question पचरा write the structure of किन बैग आज देखो structure of XiO3 हम जान xenon is outermost electron configuration 5s2 5p6 oxygen atom number is 8 oxygen atom number is 8 oxygen contain 1s2 2s2 2p2 2p4 1s2 2s2 2p4 each oxygen केतना ऑर्बिटल हम देखा अछि गोटो टिका देखिबा 2s2 outermost shell 2s2 2p4 1 2 1 1 look at here it contain two partial filled p orbital 2s 2p each oxygen atom contain two partial filled p orbital फ्लोरीन बेले गोटे होता है दीटा ताले आमर वर्तमान हाउ मेनी ऑक्सीजन एटम्स आर देयर द आंसर इज 3 ऑक्सीजन एटम्स जदि गोटे ऑक्सीजन दीटा दरकार पड़ला 3 टा पाई 3 6 दरकार पड़े 6 टा ऑर्बिटल पार्शियल फील्ड दरकार पड़िबो ईच ऑक्सीजन एटम कंटेन 2 पार्शियल फील्ड ऑर्बिटल p ऑर्बिटल ताले वर्तमान नाउ ऑक्सीजन रिक्वायर 2 into 3 6 xenon trioxide contain 3 oxygen atoms since xenon trioxide contain 6 oxygen atoms 6 oxygen atoms, we have to make 6 orbitals of xenon partial field. आम 6टा partial field करवा किमित करवा ताल xenon 5s2 5p6. So this is possible. किमित देखा 5s2 5p6 5s2 5p6 1 2 3 4 5 6. ताल केमिति हबो ताले वर्तमान इट विल लाइक दिस. 3टा इलेक्ट्रॉन एमती आम एक्साइटेड स्टेट ग्राउंड स्टेट 6टा कले आम एक्साइटेड स्टेट रे 3 इलेक्ट्रॉन जम्प्स टू 5d 1 2 3 4 5 5d 5s दीटा 5p गोटे गोटे 1 1 1 5d 1 2 3 1 2 3. तापर पे देखो इन एक्सरसाइज जदि हला वर्तमान हमें 6टा हेला काई 6टा में कहले बिकॉज ईच ऑक्सीजन एटम रिक्वायर 2 पार्शियल फील्ड ऑर्बिटल ओवरलैप कर दीटा आकार ओवरलैप कर गोटे हाइब्रिड पैक करबो गोटे अनहाइब्रिडाइज्ड देन 1 5s ऑर्बिटल then 1 5s orbital and 3 5p orbital mixed together to give sp3 hybridization and 3 partial d orbital 3 partial field d orbital remain as unhybridized. ମୁଁ କହିଥିଲି ପ୍ରତି ଅକ୍ସିଜେନ୍ ଦୁଇଟା ଦରକାର ପଡ଼ୁଛି ଏଇ ଅକ୍ସିଜେନ୍ 2 ଅଛି ଅର୍ବିଟାଲ୍ ଦୁଇଟା ତାହେଲେ ଗୋଟେ ଯିବ କୋଉଠିକି ଦିସ୍ ଇଜ୍ sp3 ହାଇବ୍ରିଡ୍ कला 1 goes to hybrid from sigma bond, the other orbital goes to pi bond. Similarly, our oxygen atom re ये गोटे oxygen, out oxygen एमती अच्छी दीटा p orbital oxygen atom O. One goes to hybrid sigma, another goes to unhybridized. Another oxygen is there. One goes to hybrid sigma bond, another hybrid unhybrid pi bond. ताले बर्तन को sp3 hybridization structure is tetrahedral हवा कथा tetrahedral contain one lone pair. So the structure is like this: xenon tetraxide O it contain one lone pair electrons. It contain one lone pair electron, sigma bond pi bond, sigma bond pi bond, sigma pi. Sigma bond is formed by overlap what? Sigma bond is formed by the overlap of p orbital of oxygen with sp3 hybrid orbital of xenon, where pi 1 is formed overlap of p orbital of oxygen with oxygen pi bond, p orbital oxygen with unhybridized d orbital. Then unhybridized pi bond, hybridized sigma bond. Then xenon trioxide shape is pyramidal, or shape of the ammonia. Its shape is pyramidal. Contain one lone pair, 3 bond pair. So this is the structure of xenon trioxide. परीक्षा पड़े xenon trioxide shape कौन? You will have the shape is pyramidal. It contains key pair hybridization. Its hybridization is sp3. If the question asks what is the structure of xenon oxytetrafluoride XeOF4, what is the structure of xenon oxytetrafluoride? Xenon oxytetrafluoride केमिति आम स्ट्रक्चर करवा आगे देख पे Xe xenon contain 5s2 5p6. It contain 1 oxygen. आम चिंता करियो देखियो इट कई ऑक्सीजन अच्छी 1 oxygen and 4 fluorine. Since 1 oxygen and 4 fluorine is there, आम केतना करियो पड़िबो अनपेयर प्रति ऑक्सीजन में दीटा 4टा फ्लोरीन. Then 6 orbitals are partial filled करियो. 6 orbitals should be partial filled. Should be partial filled for xenon. Should be partial filled. घोषिया दरकार नहीं खाली बुझीगले हिजबो for xenon. केमिति आम करबा 6 ऑर्बिटल देख पिले 5s2 5p6. So 5s2 5p6 ताले बर्तमान आम आ गोटे डी अच्छी 5d ताले आम कौन करवा 6 आम गुटिका 6टा रखा ताले 1 रेलर पेयर 1 2 3 5d रे 3 4 5 1 2 3 4 5 जंप करो 1 2 3 ऑक्सीजन रिक्वायर्ड 2 ऑर्बिटल गोटे पाई बॉन्ड गोटे सिग्मा बॉन्ड के 4टा फ्लोरीन अच्छी ताले बर्तमान द हाइब्रेशन विल बी ओके हियर द हाइब्रेशन विल बी 5s गोटे 5p रो 3टा 5d रो हमर 2टा कहीं कहला 6टा दरकार 6टा दरकार 3 3 6 है बर्तमान दरकार हमें 5टा सिग्मा बॉन्ड गोटे है पाई बॉन्ड 6टा में करदेले. सो दिस इज रिमेन एज अनहाइब्रिडाइज्ड ताले बर्तमान जो स्ट्रक्चर हम इट विल बी द हाइब्रिडेशन विल बी sp3d2 having one lone pair को लोन पेयर रहिबो आउट हम रहिबो गोटे पाई बॉन्ड रहिबो ऑक्सीजन जो 2टा करियो गोटे जो सिग्मा बॉन्ड आउट जो पाई बॉन्ड फॉर्म इट इज अनहाइब्रिडाइज्ड पाको गला पर बर्तमान देखा पिले स्ट्रक्चर केमिता होता है sp3d2 Xe रो गोटे ला डबल बॉन्ड O सिग्मा बॉन्ड पाई बॉन्ड करे अनहाइब्रिडाइज्ड देखिए अनहाइब्रिडाइज्ड ऑक्सीजन ऑर्बिटल p ऑर्बिटल हाइब्रिडल सिग्मा बॉन्ड एंड फ्लोरीन and one is lone pair is there. One lone pair is there. So this is our structure of xenon oxytetrafluoride, and the shape is square pyramidal. Shape is square अच्छी उड़े ऊपर उठे structure square pyramidal. Shape is square pyramidal. Shape is देखो square अच्छी ऊपर ऑक्सीजन अच्छी एपर किसी नहीं खाली लोन पेयर अच्छी. The shape is square pyramidal. The shape is square pyramidal. Now this is all about the structures of these compounds. Some of the compounds of xenon, fluorides, oxyfluorides, like this. Then I will be uses of use of helium. Uses of helium. First uses of helium. Helium is a very light gas, बहुत light gas, हल्का एकदम light gas. It is used for filling balloons. For balloon नाम दरकार पड़िबो filling in balloons in metallurgical observation. In metallurgical observation पे हम दरकार है observation. It is called also used gas cooled nuclear reactors. Gas cooled nuclear reactors से हम helium में दरकार है. Nuclear number B, it is used as nuclear reactor. It is also used in NMR. NMR spectrophotometer. Used spectrophotometer. Neon is used, helium gote use pale likhi paribo. Neon is used in discharge tube. Also used in fluorescent bulbs. Fluorescent bulb लगा जाए fluorescent bulb. Neon bulbs used in botanical gardens and greenhouses. It is used. Neon bulbs are used for हम देखो गार्डन गुड़ा जो रंग रंग देखा जाए लाइट से botanical gardens and greenhouses. Argon is used to produce argon is used to produce inert atmosphere, to produce inert atmosphere. Inert atmosphere argon time use करा जाए in high temperature. At high temperature. It is also used for welding of metals and alloys. It is used welding of metals and alloys. It is used for filling electric bulbs. It is used for filling electric bulbs. Electric bulb जो fill कर जाए जो देखो घरे जो होची argon. Xenon and krypton are used light bulbs. Xenon and krypton are used as light bulbs for decorative processes, for designated special purposes. So this is all about your inert gas, noble gas elements. ମୁଁ ଟିକେ ଖାଲି hints ଦେବି ବର୍ତ୍ତମାନ. Neon, argon, krypton, xenon, radon. सब तो P अच्छी लास्ट इलेक्ट्रॉन P ऑर्बिटल चाहे कोई P ब्लॉक एलिमेंट्स. Neon, argon, krypton, xenon, radon. These are P block elements. Because the last electron goes to P orbital, whereas helium, it got the last electron goes to 1s2. At number 2, last electron goes to s orbital, it have a s block element. P block element. Okay, the question, neon is s block or p block? तो मैं संख्या का neon is a p block element. Helium is which block? Because last electron जब p group रही p block element भीतर रही तो helium रे last electron goes to s orbital. So these all about your noble gases. Thank you all for patient hearing. Time है ही है ना.